Our planet faces a hidden danger. It is a threat we cannot easily see, but its impact is far-reaching. Microplastics, tiny fragments of plastic less than 5 millimeters in size, have infiltrated every corner of our environment. These particles come from the breakdown of larger plastic items. They also come from microbeads found in cosmetics and clothing. L3 microplastics, ranging from 0.1 to 0.3 millimeters, are particularly concerning. Their small size makes them easily ingested by a wide range of organisms. This poses significant risks to both wildlife and human health. These tiny particles are now found in our oceans, rivers, soil, and even the air we breathe. The pervasiveness of L3 microplastics is a stark reminder of our planet's plastic problem. We must understand the sources of this pollution and its impact on the natural world. Only then can we begin to address this global challenge. The fight against microplastic pollution requires a collective effort. We must reduce our reliance on single-use plastics and promote sustainable alternatives. Research and innovation are crucial to developing effective solutions for managing and removing microplastics from the environment. The time to act is now, for the sake of our planet and future generations. The journey of L3 microplastics into our environment is multifaceted. A significant portion originates from land-based sources carried by rivers and waterways into the ocean. Wastewater treatment plants, while essential for sanitation, often fail to filter out these tiny particles. As a result, millions of tons of microplastics are released annually into aquatic ecosystems. Atmospheric transport plays a significant role in the global spread of L3 microplastics. Wind can carry these lightweight particles over long distances, even to remote areas far from human settlements. Studies have shown that microplastics can travel thousands of kilometers through the atmosphere, eventually settling onto land and water bodies. Road runoff is another significant pathway for microplastic pollution. Tires, brakes, and road markings all contribute to the release of microplastics, which are then washed into drains and rivers. Once in the environment, these synthetic materials persist for hundreds of years, posing a long-term threat to ecosystems and human health. The Ganges River, a lifeline for millions in India, provides a stark example of microplastic contamination. A recent study revealed alarming levels of L3 microplastics in the river's water, sediment, and even the air above it. This pollution is particularly concerning given the river's cultural and ecological significance. The study found that microplastic concentrations were highest in areas with high population density and industrial activity. This highlights the link between human activities and the release of these pollutants into the environment. The presence of microplastics in the Ganges River is a serious threat to the health of both humans and wildlife that depend on it. The impact of L3 microplastics on biodiversity is a growing concern. Aquatic organisms, from tiny zooplankton to large whales, are ingesting these particles, mistaking them for food. Once ingested, microplastics can block digestive tracts, leading to starvation and even death. Microplastics can also absorb and accumulate harmful pollutants from the surrounding water. This presents a further threat to marine life, as these toxins can bio-magnify up the food chain, reaching higher concentrations in top predators. The long-term consequences of microplastic ingestion on animal health and reproduction are still being investigated, but the evidence so far is concerning. The presence of microplastics in ecosystems is a stark reminder of our interconnectedness with the natural world. What we put into the environment ultimately affects us all. We must act now to reduce plastic pollution and protect the biodiversity of our planet.